Hello everyone, it's Peter from the R3 DevRel team, and today I will be your host for this workshop. It's the first workshop out of the 3 workshops we're gonna do in August. Today is the Corda Developer Bootcamp. The second one next Thursday will be cover Corda accounts, and then the third one on the third week of August will be on how to write tests for your CorDapp. And we will also be launching shorter video series in the second half of the month, and then we're gonna continue that series. So that will be also be one of our experimental projects. So stay tuned, and let's begin. So we're gonna start our presentation with some Corda references, because after the workshop, I want you to join our Corda community and stay in touch with us. First, it's the Corda YouTube channel. That's how you see me right now. And we have the Corda Slack community. You can join us at slack.corda.net, and you can read our documentations about Corda technical implementations and other stuff like how to build a net. What's going on with the Corda network, and etc. on the docs.corda.net. We have a free training site at training.corda.net. Our GitHub repository is github.com/Corda. And lastly, you can reach out to me, and we have David in the chat at devrel@r3.com, and follow us on Twitter at Corda Blockchain and Inside R3. If you enjoyed today's workshop, make sure you tweet about us at the end of the session. Sure, let's begin. Today's workshop is about CorDapp. So let's talk about CorDapp. And let me make myself smaller so you can get the best out of the content. Cool, let's go. So CorDapp. CorDapp stands for Corda decentralized application. Someone may ask, okay, then what is a decentralized application then? Decentralized applications are computer applications that runs on distributed computing system. It's also sometimes referred as a smart contract in other blockchain communities such as Ethereum. Oh, my animation didn't kick in. So now bring back to CorDapps. CorDapps are simple binary jars that store in the Corda nodes. So each Corda node can carry multiple CorDapps. For example, in a real life example, you can have a supply chain running on your node, and then also have an insurance CorDapp running on the same node. In today's short the demo CorDapps, I have a network of 3 nodes: node A, node B, and node C. And you see all of the 3 nodes has hello world CorDapps, and only nodes B and C has a whistleblowing CorDapps, so they can chit chat privately. So that's how you can deploy CorDapps on the node. And if you don't know what's a CorDapp, you can go through our previous video of the Corda intro. We done one of the workshop on the really high level Corda 101 Corda overview last month, and you can go to that video and then see what's a CorDapp, what's the Corda network, and then etc. That belongs in the Corda 101. Today is a technical session, and let's actually go into the implementation, the components of CorDapp. So the CorDapp we just referred is the smart contract on the Corda network, and it consists of 3 components: states, contract, and flows. So the states are the object in Corda. They can get consumed, updated, and stored. And the contracts verifies the transaction. So if you think you see the screenshot right there, these lines are the actual codes in your CorDapp contract file. And if you want to do a transaction with your counterparty, it has to go through route number 1, route number 2, and route number 3. And if any of them actually, has has failed, then the transaction will get rejected by the contract. And lastly is a Corda flow. It represents the business logic, all the calculation, verification, signing and data writing will be in the flow. And the Corda flow is what gets executed in your Corda system. So you don't call a state, you don't call a contract, you call a flow, and then that flow can actually do all the magic behind the scene. And actually, let me see if you can see this side. This is actually a simple Corda flow. Has node A, node B, and a node tree. And then you see the journey is actually the business flow. Sending an update, send to party B, party say, oh, I verified it, go back to A sent to the node tree service, everything look fine, no double spend, go back to node A, and then node A says, oh, okay, it's all good, it's here. You can see it, it's here. Everything's all good, broadcast to the participating parties, and everything get updated. Cool. Is there any questions? If you have questions, you can drop in the chat. My colleague David, he will be answering all those questions for you. Cool. Let me quickly change my screen right here, because we're gonna go into implementations. All right. Yeah. Cool. So let's talk about what we're gonna do today. So for today's session, we are building a token CorDapp that showcased the change of ownership of a token. So this is the best example to demonstrate how Corda enforce peer-to-peer data transaction and immutability and all the blockchain good stuff. Because once we wrote the CorDapp, we're gonna see three parties: party A, party B, and party C, and we're gonna do a token issuance, right? Change of ownership. This token be from A to B, or like this state. And then now party B owns it, right? And then party C doesn't know anything about transaction. So we're gonna all demonstrate that. And I'm gonna show you guys how to implement these three files all together today. So the token state.java, token contract.java, and then token issue flow initiator.java. Let's begin. So for token state, what we are seeing here is in the box is actually the three properties of the token state. The token state, again, I'm gonna reiterate again to just reinforce your memory. Token state are the data exist in nodes that get consumed, updated, and eventually it's get created, updated, and eventually get consumed by the transactions. And here today we talking about token state. So the token state's gonna have three attributes: the party issuer, the party owner, and then the amount. It's just a very simple state. So this token state gonna get created, get transferred, and for the simplicity of today's workshop, we will not do the consumption part of the application. It's just gonna get created and then sent to the other party. Cool. Let's go to IntelliJ. And yeah, here I am. Become even smaller at the bottom right corner. So what you see right here is actually the code repository of today's bootcamp. Is github.com/corda/bootcamp. And we also have today's slides here in the webinar slides, so you can it's a PDF. I upload them last month, and you just download it, and then you can follow this video. This workshop also gonna automatically upload to YouTube after the session, and you're gonna follow it and then implement it, and then at the end of today's workshop, I'm gonna show you actually how to run it. So by the end of this 1 hour, you're gonna have a running CorDapp. Cool. Let's go to IntelliJ and actually looking at what's going on here. So let me actually minimize everything. So let's see. So we on the top. I don't know if you can see it clearly, but IntelliJ doesn't zoom in on the folders. But on the left here, on the the navigation panels, you see like .idea, .settings, .vs code. So those are just like the file that we uploaded for you to have those. You see these things working out of the box. So those are just like editor configuration. So don't worry about it. So the config is where we basically tell where you build your stuff to. And then the Gradle is, again, it's a tool that we're going to use. The library is the Quasar, the jar that we're going to use to build the CorDapp. So none of those are like, you don't need to know any of them at the moment. So all the meat is here. We have a Bootcamp folder, and then this is a token state, .java, token contract.java, and then token issuer flow initiator that we said that we are going to implement. And as a good development practice, we want to be test-driven development. So these are the tests that we want to fulfill at the end of the day. And this is the build Gradle that helped the Gradle after we finish the implementation, help it build the project. And then we also have the task at the bottom called the deploy nodes. It's use Corda formation that's automatically use the bootstrapper that deploys the network, so you can actually run. And then the README, and here you see solution.md. So if you have any issue following the workshop, or you got confused on some of the implementation, or I'm going too fast in the later part of today's workshop, you can always refer to the solution.md, so you will have a running version of the code. Cool. Enough talks about the structure. Let's actually see what's going on token state. So token state here is very like everything is empty here. That means we need to write everything. But it's actually very simple. So I'm gonna quickly show this again. So if you see here, we said there are only 3 attributes in token state. So all we need to implement is these 3 attributes, and we can actually type it right here. Private. That's also like how you define the private attribute anyway. We want to make it final because we don't want it get easily to change, and we want final party owner. And last one, private final int amount. So this actually, corresponded to what we said in the presentation. So those are the 3 attributes. But if you have been through our Corda 101, we said like we gave a little bit more details. We give a little bit more details about what's a Corda state. So Corda states always implements a interface called contract state. So every single Corda state in the Corda system, Corda applications is a contract state, no matter what. No matter you come across is a token. We have a token SDK. You go into the deep core of token SDK, you're gonna find out that fungible token or non-fungible token of the CorDapp is a contract state. That's just like no matter what. And with the help of your editor IntelliJ, you can press the option and enter. It actually tells you, okay, implement the method, and then this is the override method that you have to implement for every single contract state. So this is the shortcut. For Mac user is Control Enter, and for Windows user is Alt Enter, and then it's gonna automatically implements this get participant method. This is override, and then now we are satisfied with the first red curly lines. We don't want any red curly lines. So what are this is complaining? Option Enter is complaining. Oh, it doesn't have a constructor. It's very simple to do too. Command N, constructor, and then select all of these like attributes. Wait. Okay, hold on. So I forgot one thing. So you see, we have a override method that we need to take care of. It's called get participant, and then it's a list of abstract party, but we never actually mention it in our private attribute. So what we're gonna do is actually we're gonna define it right here, and we're gonna just call it participants. And now we are good with all the required private fields, private attribute, and we can create our constructor altogether. Done. And with Windows user is again it's Control N. So this is a shortcut of IntelliJ. It's like make our life much easier. But let's actually look into the constructor here. So we have we have the issuer, we point them to the attribute. We have owner, we point them to attribute. We have amount, we point them to attribute. And then lastly, these participants. So we don't want them to be defined when you create a state. We actually want the participant to be a list of the issuer and owner, because it makes sense. A token transaction only needs two participant, which is the issuer and owner. I don't want to when I create a state, I don't want a random person saying, oh, I want to be part of the transaction too. So we actually hard code was what is the list of abstract parties, which is the participant list that we're going to return. So we just create a new array list. We don't need to define what it is. So and what we can do here is participant.add issuer, and then participant.add owner. Okay, so now officially we are done with our constructor. And after we added to the constructor that we initialize the private field, we actually return it, because that's the whole purpose of we initializing it. Again, we want to be lazy. Command N, now getters, select all, implement, done. So this is very one of the reasons why we a lot of our internal engineers use IntelliJ, because it's just very convenient. But don't worry, we don't favor editors, because they are just tools. They work for us. We don't work for them. We also have we can also doing this on the VS Code or Sublime Text if you want to do go very lightweighted on this. Cool. So basically, yeah, this is it. This is the implementation for token state. But before we move to the token contract, so one last thing here is line 14. If you download the code, you're also gonna see this. It's there's a thing that get commented out called belongs to contract, and then it's point to the token contract class. So if I uncomment it right now, it's gonna give you a red curly line, and everybody hates red curly line. But I have to explain to you here, what is this line? So in Corda 101, in that workshop, we explained that every Corda state is pegged or is connected, is linked with a contract. So when you do a transaction, if you use that specific Corda state as an input or output, right, that transaction will find that contract and then verifies whatever you want to do with that state. For example, in the contract, I define commands, which are the intention of your transaction for that specific state. For example, we're gonna later see here in the token contract, we're gonna all do it together. Is I'm gonna create a command called issue, right? And then what I'm going to issue is a token state. And this line of code basically tells the Corda node, tells the system, whenever you want to do issuance actions on that state, go to this contract file and then find the verification code and then check it. So that's why we need this line of code, and that's the purpose of is an annotation of the class. But besides that, so what I'm trying to say here is let's just pretend we don't see this red curly line right now, because after we implement the token contract file, this curly line will go away. Cool. Any questions on the token state? Again, it's very simple. I basically finished this implementation in like 2 minutes. Questions? Let me actually check the chat. I see questions. Can I make a token issue to a single node specific? Yeah. That's what we are going to do. Yeah. And I think David also answered it. So if it wasn't clear enough, you can actually get back to him. Cool. All right. Let me continue. Now the second thing is we're gonna go to token contract. The token contract is token contract. Hold on. OBS presentation mode, right? Because I want to talk about contract. Right. Yeah. Okay. No. Cool. Token contract. So token contract is the thing that verifies the transaction. And as I explained before, so the Corda ledger is updated then through transaction in the flow. And the contract verifies the validity of the transaction. And right now you're seeing a success case right here, because in the transaction, you have the input, which is the existing state. You do some transaction calculation, you have your desired output state, which is the output. You encapsulate them into a transaction. That transaction has input, output, and then like many other. You can have attachment, you can have timestamp, you can have like whatever stuff you want to put. You can even put a PDF as an attachment in your transaction. And then that transaction will go through contract rules. Very specific rules. Rules number 1, number 2, and number 3. And the rules need to be followed during the transaction. And if all pass, great. Ledger updates and it's get recorded on the ledger. But what if it fails? If it fails, for example, one of the rules fails, the transaction will automatically rejected by the Corda, and the ledger update and the recording will not happen because the Corda node rejects the ledger updated proposal. And what we are trying to do today with our CorDapp is we are writing a contract for the specific action of issue. Right? When you issue a token from party A to party B, what's your action is, you create a state out of nowhere, and then you give some property to your state. That's like the state creation. And then you issue it. Basically, you give it to the counterparty. And in our case, it's party B. And there are specific rules that we need to follow. Like just from what I just talked about in that specific issue actions. In the transaction, it needs to have 0 input, because you creating this out of nowhere, right? And it need to have only one input. I mean, you can have multiple outputs, but for the sake of simplicity of today's workshop, we only gonna have one output, right? And that output, the issuer has to be like the participant of the issuer has to be the issuer and owner, because I need to make sure that I create the stuff, I give it to you, and then on the stuff that I created, it says I created, and then you receive it. Because if that state that's I send to you says you own it, you created it, then I'm the like, for example, buyer of the state, or I'm the recipient of the state, then it's all messed up. Like, we don't want that. We want to have a specific rules to check for it. And lastly, it's just like we want to showcase you can have a business logic implemented in the contract. Is the amount has to be positive. It needs to be more than one. Otherwise, why are you issuing me a token that has negative value? So does that mean that I owe you money now? So those are the rules that we need to implement. And I also said that Corda contract rules are literally the code. I'm not kidding. So what you're looking at here is basically the implementation of the code that we're gonna write together. So public void, verified, ledger transaction, that's the parameter, and the inside functions, we have 6 different rules. We wanted no input, we wanted only one output, we wanted output to be a token state. I don't want you to give me a random state, I want a token state. That's what we agreed to, right? And then the issuer need to be a required signer, the owner must be a required signer. So that's when I receive transaction, the transaction has both our signatures. And lastly, the owner amount must be positive. So this is all respond or corresponded to our use case, which shows on this diagram. Cool. Let's begin the implementation. I'm gonna switch to my code again, and then bam. Cool. So with token contract, let me explain what we have here. So the top class is class token contracts. Again, if you watch the Corda 101, we briefly talk about every token contract. It also implements a contract, implements an interface called contract. So we're gonna do that first, because first thing first, right? Contract. So that's actually, you see the curly line here goes away because belongs to contract. So now I jump back to the token state. The moment that we label the token contract as a contract class, the red curly line of the token state goes away, because now it's the annotation recognized token contract class is literally Corda contract class. So we are good to continue. So I just want to tell you that you see it's been taken care. And the next thing is here is a static ID. So we give a name basically to every single contract of your CorDapp, because once we hit a production level CorDapp, you're gonna have tens or hundreds of Corda state, or like that's an exaggeration, but at least like 10 state or something like that. And then you're gonna have 10 contracts at the same time. And then contract can evolve actually, because your CorDapp can evolve. You can have contract version 1, contract version 2, you can have multiple contract, and you're gonna like run into that advanced stuff we are not gonna cover today. But basically every contract gonna have a contract ID. You can refer them, normally it's automatically referred in the Corda flow. I'm gonna cover that later. But you can also manually add contract ID to your flow when you build a transaction. Is very mischievous stuff. Next thing is the verify method. So this is a method gonna get automatically called when a transaction carries a state that is connected to that specific contract state. And in our case, whenever a transaction is carrying a token state, the contract flow, the token contract will automatically called, and then the verify method with automatic triggers. And lastly, at the bottom, we see an interface. It's called comments. It extends the comment data. So this is the class interface that I mentioned before. Is this indicates the intention of your transaction. You're gonna specifically says this contract, this transaction carries issue commands. I can also write here is like a class transfer. I mean, we are not gonna do anything today about the transfer commands, but I can declare them. Yeah, it's not gonna do anything, but like that's basically what's going on here. This for this interface, and after you have different commands, what you're gonna do? So the different we're gonna write if else method in the verify. So like for example, I'm gonna just like if this is issue comments, and then something gonna happen to take care. Else if this is transfer command. So this is how we take care of the different intentions of the transaction that carries the token state. Cool. Let's actually get started. So you see in the verify method, we're gonna specifically write code for each of the commands, each of the intention. Then the first thing is we need to actually extract the commands out of the transaction, which is here. This is a transaction. We're gonna, there are multiple ways to do them, but I just want I want to be a efficient developer. I'm gonna use some domain-specific language that R3 has developed to help Corda developer to basically save time. So command with data with parties is the stuff that we are getting out of commands, and let's just call it commands. And we're gonna use a domain-specific method called require single command. I think it's here, right here. It's contract domain specific language. So it's not a Java thing. It's not a Kotlin thing. It's a Corda thing. So we create this method for you to write less code. And what we are getting here is in all of the transaction. No, not in all. In the transaction, we want to first get all the commands, and then we are looking specifically for token contract dot commands dot issue. No, not issue. Sorry. So no, we want the class. So this gonna get us a comment regardless of like the type. You can also get that specific issue using a different method, but today we just want to get a comment regardless of the intention. And the next thing we want to do is we want to write our if else loop. So if, right? And actually, let me make the comment. So first thing first is comment dot get value. So this actually gonna show that whether it's an issue command or a transfer command, and then we want to say instance of token contract commands issue. So basically, this says if this is issue command, right? And we can define like here is else if else if command get value instance of token contract commands transfer. So I'm just like giving an example. And lastly, we want to say that if the commands of the transaction is none of the two, that means like someone is sending me a like very random transaction that I don't know of, right? I'm gonna throw a illegal argument exception like unknown commands or something like that. You can arrow out there. And let me actually make this, yeah, right here. Rules for issue for transaction that carries the issue command. Transaction. Cool. So basically, this is the structure that we're gonna handle the verify method. We're gonna get the commands out of the transaction. Like we don't care what it is, but we're gonna write if else loop to identify make the transaction go through the specific rules that it needs to go through. And let's quickly, go back to the rules that we want to implement here. We have a couple rules. We have 6 rules. We have no input, right? And we have one output. And we have output must be token state. And we have the signers, right? I'm gonna go quick. 2 signers. And then lastly is the amount need to be more than 0. So let's see how we can implement them one by one. I was copying this to the code. First, let's see no input. Quickly grab some water here. So actually inside of the if else the if loops, when we actually writing the contract rules, we can use another contract DSL, the domain specific language that the Corda R3 try to make everybody life easier is require that. So the require that is basically a method that you can basically write your requirement as simple as how would I say it? Logically compile the language. So here we have the required object here, and then we want them with a method called using, and then we can have the message here is transaction must have no input. And after the message, we want to have input. We want to check. We want to check if the inputs, like transaction dot get inputs, input state dot is empty. So we can do that. And that's corresponded to our first rule. And our second rule is only one output. We can also do that. Is again require using I gonna be quick with the error message is just like one output. And here we have a transaction dot get output states dot size equal 1. I mean, you can also get the input, get the outputs like, you know, somewhere here, and then to make the code like make it here shorter, but it's really up to you. I'm just like, you know, writing this on the spot, so I gotta choose whatever I want to do. Yeah, I think the solution file declare the get outputs like outside of the if else loop, but it doesn't matter. So output must be token state object, right? Transaction dot get output state dot get. I assume there's only one, and because we already checked that transaction output size must be 1, so I'm just grabbing the first one. Instance of token state. And also you can see like sometimes the order of this can matters, but if your goal is to write, you know, very I mean like your goal is write correct code, if that achieve like the order of the contract doesn't matter. But for example, if I have I accidentally write this line of code above the checking for one output rules. if I accidentally have 2 outputs, it's gonna error out with the wrong error message, because it turns out it's actually you fail because you can only have 1 output, but you have 2. So I'm just pointing that out. With 2 users, I'm checking that require that using. Yeah, I think for this one I need to take some extra step, but maybe not. Issuer must be one of the require ED signers. Transaction dot get output state dot get 0 dot get wait, no, hold on, get 0 dot, okay, right, okay, I need to do that. So I need yeah, let me just try to do that to make the code shorter. Token state dot output equals transaction. And for here, what need to do is comment dot get signers dot contains output dot get issuer dot get owning key. Okay, is this, why is this what is this complaining about? Contract say. Oh. Token state, yeah, cool. And then I'm gonna do the same, because it's 2 signers. We want to check both signers, right? Using, just gonna copy paste this to save the time. Owner must be one of the required signers, and it is exactly the same thing. Let's copy paste this and then change this to get owners. So basically, like, this shows why you need a getter. you need getters primarily because this you need to write very thorough contract. So make sure that you don't end up with bad transactions. And the last one is required using messages amount more than 0. And I want to use this output, the get amount bigger than 0. Bigger than 0. So if you don't use the domain specific library, require that, and then this syntax, you can also like just keep writing, if else, if this fails, if that fails, and then your logic will need to be sort of like reverse, because if you want your contract to success when you have amount that is positive, so you will write your if condition, basically if the output gets amount less than 0, and then like throw exception or something like that. So I really just suggest use the domain specific library. Like it's gonna save your time like a huge amount of your time. But right now I think we are good to go, because the contract is fully implemented with all the comments within each other, and then token state is no curly line. What we want to do here actually is to check if we really successfully implemented it, or like we were just like we were faking it. We can check by running the test. We want to be test driven development. We just like we don't have time to write the test altogether. We only have like less than like we want to finish a session in less than an hour and a half. But when you implement your own CorDapp, make sure you start with a test, right? So let's see what's going on with the state test now. I just run it here, and the test result should coming out build. Okay, so yeah. Why is there? Okay. Anyway, so state has run again. So there was a random dependency there that is not used. My laptop is slowing a little bit, but okay, cool. Yeah, every time you try to like blame the laptop, it's just gonna get it through. So for state test pass, and if we look at the state test, it's like token state has getter for issue owner amount. Token state implements the contract state. It's all like the small details of the token state. So we will not go through all of them. We just want to make sure that our code works. And then now let's go to the contract test. Again, select everything, uncomment everything, and run the contract test and hope for the best. I think we have a 6 or 7 contract tests, and that will take like 30 or some seconds. While it's running, I will quickly check for the chat. Sounds like we are good with the chat. David is all answering all the chat. That's great. And at the same time, going back to the test, we have all passed the test. Make sure I don't beat my tongue. Yeah, test passed 8 out of 8. Great. Then I will actually move to the last thing, the token flow. Any question on the contract test? Drop in the comment, drop in the chat, David, or I will cover that when I have a gap time. Cool. So going back to the presentations, the next thing is the last thing is Corda flows. So Corda flows execute the business logic, and the flow consists of two classes, the initiator and the responder. Today we are only going to implement the initiator part and the responder is already pre-implemented. In the Corda 101 videos that you can go through our channels and find it. It's just titled Corda 101. The initiator is what triggers the action, and the responder is what the counterparty gonna reply to the action. For example, I send you some state, right? On my end, I initiate the flow is I'm creating the state and I send it to you. At your end, when you receive it, you're gonna first automatically check whether it's valid or not. Also, at the same time, you can decide where I'm gonna put it, right? I might triggering another internal transaction to take care of the action of receiving your transaction and you're receiving your state. So those are the things that you can implement in the responder. And for the sake of simplicity of today's workshop, we are not gonna do anything with the responder. And the responder is actually pre-implemented. Same is also pre-implemented in the Bootcamp CorDapp repository. So just don't worry about it. And what we're looking at here is this diagram you are looking at right now depict the simplest flow in CorDapp. One node is trying to propose an update, and the other one is just like, okay, sure, propose the update. I will check after like I verify the transaction. I will just record it. And the flow is basically I think I went through this like from the previous slide, but it's just like it's a single stream business logic. We can go over multi nodes with Oracle, with observer node that is not necessarily in the transaction but will receive a transaction later when you broadcast to them. So we can go through a very sophisticated and complex flow business logic or flow logic in a different workshop. And actually comment in the chat if you want us to have a session on how to build a sophisticated, or how to think about building a sophisticated network on Corda. And yeah, sure. Enough talking. I will go to the code. So we go to the token issue flow initiator. It actually already tells you like what are the steps that you need to do. Like to do 1, to do 2, to do 3. But I just gonna implement it. So the first is we create our token state. Token state is like how you created any Java object. Token issuer owner amount. Yeah, I will implement the code and then I will go through it. Yeah, I think I'm a little bit too talkative. We're gonna running behind a little bit. So create a token state, and second thing is write our token contract to control. Yeah, okay, yeah. Don't worry about it. Yeah. So the first thing is create a token state with our issuer, owner, and amount. Like we define them in the constructor, who's gonna own it and who's the amount. And then the issuer is always ourselves, like we declare here. We get to reference our own identity because we are initiating the transaction. We are the issuer. And the next step is building a transaction builder, because that's what's gonna carry the token. So new transaction builder, and then the parameter that it takes is a notary. because every transaction builder needs to know which notary service that we want this transaction to verify it from. So in a network, you have a multiple notary service running on the network, and each of the notary service can run different consensus algorithm. For example, you can run BFT, you can run Raft, you can run round robin, you can run whatever consensus algorithm. And this line of code is where you choose that the notary service. Right now, we are just picking one because we are using a Bootstrap network and there's only one notary service on the network. That's why we just picked that one. But production level CorDapp, you will never use get zero. Well, that's gonna error. First, it's gonna error out, and the second is like you actually don't know what's the first one in the net. What's the first one in the notary list of the network? Maybe you don't want to use that one. So you will always be specific about which notary you want to use. You can like pass it as a parameter or like hard code here saying like all my CorDapp go through that specific notary. So that's like a production level. And the next thing is we are enriching the transaction builder by adding output. Adding output state, and what is it is the token state that we created, and like, yeah, that's fair enough because we created it, we want to use it, right? And next thing is transaction build. We're gonna keep enrich it. Transaction builder add command. So we wanna tell the Corda node that what we want to do here with this specific flow. With this specific flow, transaction, and that specific token state. And what we want to do here is we want to actually define why I keep hitting M. We want to make it a token contract. Token contract.com. No, I don't want that. Comments.issues. And that's actually our comments. And we want to define who are the required signer of this transaction is issuers, and also at the same time is owners owning key. Done. So after we after we add the comments, the transaction builder is done. Like think about it, the transaction, now we have one output, and that output is a token state. Just revisit our contract, and then we have a one comment, and that command is an issue command. And then with that issue command, we specified two required signers. One is the issuer, one is the owner. And now the transaction is fully built. What we want to do here is we want the transaction builder to verify it with Service Hub. So Service Hub basically is a service engine of your own node. And the first thing we want to do is before we send to the counterparty, we want ourselves to verify it. And that's this line of code. And then the following code is we initiate a flow session with the counterparty because we are the issuer, the counterparty is the owner. And the counterparty, next thing is we sign ourselves. I mean, like the order of this might be wrong, but it really doesn't matter. It's we verify with our transactions, and then we sign them, like ourselves. We sign it, and then we start sessions. Like we create a session, and then this one is we collect signature from the counter session. So basically, these 4 lines of code says, I verify it, I sign it, you verify it, you give me a signature. And then the lastly is a finality flow, is with all is fully signed transaction, and then I'm gonna broadcast to the session, which is you, because I know my transaction, after I have all the signatures, I'm gonna record it to myself, but at the same time, I wanna tell you to record it as well. So this is the last step. And move to the top is private attribute, constructor. I didn't go through them at the beginning because it's just simple Java stuff. And this two is the defining the annotation for the token issue flow is if it's initiating a flow, and then it's startable by RPC. Startable by RPC meaning that can I call it from the shell, because yeah, it's a little bit advanced because some flows they are startable and some of them are Corda service. And for Corda service, they cannot triggered by sort of human command. It's triggered by other flows, but that we can talk about that in a different workshop. But yeah, but that's about it. That's like how you implement a token flow. Contract flow. And contract flow basically execute the business logic as we indicated here. Okay, without further ado, too much talking. Let's see if it actually works. So we're gonna comment out all of this and then hope for the best that it works. So I can actually show you that it runs in the terminal, and you can actually see that all of the transaction in action. Cool. It's 3:01 right now. Sorry, it's I probably gonna take another like 5 to 10 minutes just quickly show you guys how to run the CorDapp, how to deploy the nodes and how to run the CorDapp. But I do want to say again, like this session used to be 8 hours. Man, we really try to make it work in less than an hour and a half. From my past experience, is one of the flow. If one of has passed, then all of them will pass. It's just like, bear with me. It's gonna take a little bit of time. I'm seeing interesting comments about of course the one-on-one level stuff has no practical use in real enterprise application. True. However, for today's session, for today's workshop, we just want to help the beginner developers to get their hands on CorDapp development. We will cover sort of a bit advanced stuff in our next session, which is Corda accounts. So that's focused on the scalability and how to write. It primarily focuses on scalability. It's more business sort of relevant, because think about it, like deploying. No, I will be honest with you. Is like if you read our documentation even, so it says deploy a Corda nodes on a cloud service. It's normally costs like a couple $100 per month. I mean, it's not that expensive, but it's also not cheap. So Corda accounts will be a key features that can help you deploy multiple accounts on a single Corda node. So you can host your, if you are a management service team, that you can host 10 of your clients just as Corda accounts. So yeah, let's stay tuned, and then I see you in that workshop. I make sure I will I will try to find you there, man. Cool. Back to the CorDapp. Task pass, woohoo, meaning that I didn't mess it up. Implementation. So last step is how we actually run this CorDapp and see it in action. So I'm just at this CorDapp folder, and before I do anything, I want to check if my Gradle working properly, if I can clean the project folder, right? First thing first. Okay, build successfully, and now I'm gonna run the Gradle task called. I don't need to clean again. Deploy nodes. So yeah, let me hit enter first and then show you guys. So what that is that's a Gradle task in the build Gradle. Here using chord form to deploy a Bootstrap basically build a project into a Bootstrap network. It doesn't necessarily start a network; it only builds it. But it's the first step, and that's how you actually call them. Dot slash Gradle W meaning wrapper. I'll work on my pronunciation. Wrapper. So that's here. If you see my mouse here, so we have a Gradle wrapper that helps to do all of this. And what you see here is actually it's generating the node directory for party A, party B, and party C. Again, remember I was saying that this sample is the best to demonstrate the peer-to-peer communication and then the immutability, privacy, and other stuff, because we want to do an issuance from party A to party B, and we want to show that party C has know nothing about the transaction. Cool. Normally it's take about a minute, like 20 seconds, and also like I have a lot of software running right now, and I'm streaming. So just bear with me for another 5 minutes. Okay, it really might be I have too many stuff running. So maybe let me try to close the IntelliJ. Oh. Okay. Yeah. I see a comment said, please go back to token contract in order to see its code. Sure. I mean, I'm trying to deploy this. I don't want to open IntelliJ right now, but let me do something for you. Here. So this is a Bootcamp repository, right? And here has the solutions. Aha! and then go down to the token contract. You can see all the implementation here. I was coding differently because I didn't just copy paste. I mean, it would be much easier. I just copy paste, but I was actually live coding it. So my code is a little bit different, but it's the same thing. The goal is you just pass all the tests. That's all you need. So here, solution.md Bootcamp repository. Cool. So let's back to the terminal. Finger crossed that it will actually deploy. This is very painful as I'm just waiting for this. And let me check if I have a Docker running. I doubt it. Yeah, my laptop is really slow right now. I used to laugh at David because he tends to run into these issues quite often, but now I guess it's my issue now. Okay, I got nothing running on my Docker. It's just okay. It's just right at this moment my laptop decides not to work. Okay, let me keep shutting down stuff because I really want to show you guys this. So let me close the PowerPoint. Okay, this is ridiculous. 2 minutes and 40 seconds. We finally get it running. Normally it only takes 1 minute and 20 seconds. Maybe because it's weather and I've been streaming for an hour. So yeah, let's see. So what you need to do here is make sure that you don't run Gradle wclean because yeah, I was joking. So we're gonna go to the build folder, and then we go to the nodes folder, and then you're gonna see a commands called run nodes. Okay, let me actually show you that. So right now I do ls. I'm in the project level folder. I'm gonna go to the build folder. I'm gonna go to the nodes folder. I'm gonna see all the nodes here. We have a node tree, we have party A, we have party and party C. We also have their node configurations. That's what the Bootstrapper was used behind the scene. And then we see the run node for Linux like machines, and also we have the bat for Windows. So I running on a Mac, so I just gonna run those. So I think I also gonna run into like some computing power issues, because it's just like if I deploy them in 2 minutes and 40 seconds, some of the nodes just won't start up because my CPU is really at the maximum capacity right now. But finger crossed, hope for the best. You never know, right? Yeah, good. I think everything starts. Yeah. And also, like, what's good about Corda is you see every time you see a random joke. I won a $3 million lottery, so I donate a quarter of it to charity. Now I have a 299.75. Yeah, but it's only a joke. Don't worry about it. We are still waiting for the node to start. Yeah, if you just working on your local machines, it's not gonna be that slow. Yeah, I think it's because I have been streaming for quite long time, and it's a hot day. I mean, yeah, it's not that slow on when I work on it, but it's only slow like when I'm like trying to stream it. Yeah, it's loading the local host, everything. Normally the nodes will start up in like 20 seconds. Yeah, that's about right. So right now you see my node tree startup. My party A is still trying to. This is embarrassing, man. Okay, cool. Let's see party B, party C. Okay, good. All my babies are up. So we can check like if our CorDapp is successfully registered by typing flow list. And flow list, you're gonna see the Bootcamp token issue flow initiator. And that's actually a good point, because you don't see the responder there because it's not startable by RPC. That's one of the annotation that we saw in the code. So that's again, everything is related back to each other. So let's just like quickly run a command here. So flow star token issue owner party B among 99 star. And again, on a normal day, it's not gonna be this slow, but today is just a bad day. Done. And actually, party B, we can check for it. We can run vault query contract state bootcamp dot token state. So like these two commands are also in the README of the repository, so you can like find them. And the state are having like this is basically the state that's saved in your database. You can actually see the issuer, owner, amount, and the random, like all this stuff. Like don't worry about like this data being like leaked out, because you can only see this because you are logged in as a node operator. So basically like you own this software, and you are logging as an admin assets. If you just log into the database, you're gonna see like random blurb. It's encrypted and it's serialized. So this information will not easily to display it on a non-Corda system. Like right now we are in the Corda system. That's why you can see all this like sensitive information, like who's the issuer, who's the owner, what's the amount. Okay, so that's the security level. And now let's take a look about like the peer-to-peer communication level. So this is party C, right? In our transaction, we never brought up party C, so we should see nothing here. And nothing. So in their database, they have 0 token state. It's not even like they don't see the state that transact being Corda between party A and party B. They see nothing, right? Because like nobody, like party C is just not involved in the token transaction that we just did. Cool. That's just like a quick demo that like really took a long time, but that's how you run a CorDapp in a shell. You can also start your client and then write to your web server, and then react with it with your your existing platform or software, or running with a front-end app. I'm actually working on a tic-tac-toe game that like coding a tic-tac-toe game on Corda with count features. So and our goal is actually deploy it on a live server, so all of you can actually play the game when we have a front end. So I will keep working on that, yeah. So that's all the information for today's workshop. Let me actually start presentation. Let me actually shut down all the nodes so I can have my CPU back and open the presentations, and then just say a quick reference. Again, you are seeing me on the YouTube channel / Corda blockchain, and we have a free training site at training.corda.net. You can join our Slack community by going to slack.corda.net. Our documentations is on docs.corda.net, GitHub repo /github.com/repo. If you have any questions, email us at devrel@r3.com. And I actually see David was telling someone to email us directly. And lastly, if you think the workshop is helpful, I'm reading the chat. Did you say that the webinar will be available on GitHub? Yes, it is. It's actually there right now. If you go to the repository, there's a folder called webinar slides. Well, this is a PDF, but that PDF is basically the presentation. And if you like the workshop, make sure you tweet us, or if you have suggestions or recommendations on how we can make it better, also you can send us email or just tweet about it. And our next workshop is on next Thursday. It's a little bit more advanced topic. It's about Corda accounts, primarily focusing on how to build a scalability. That feature is primarily focusing on how to build more scalable CorDapp when you're dealing with whether it's a consumer-based application or is like you are running a managed service with multiple clients that's thinking deploy their own node is just too expensive. So that will be covered in our next Thursday's workshop. And again, I'm Peter Lee from DevRel team at R3. I hope to see you next time.